Fine. Here we go. Take it away, Yuval.
Hi, everybody. I'm Yuval. I'm a PhD student at Haifa University, and I'll be talking about tracking the flights of moths to pheromone lures under bat predation pressure using event-based cameras. So tracking insects in flight is a long-standing challenge, especially because separating the insects from the background is a challenging task with frame-based cameras. But event-based cameras operate differently. They only capture movement. So therefore, they are ideal for tracking small, fast-moving objects like insects. To demonstrate their capacity, we tracked the flights of cotton ballworms over tomato fields, and we used pheromones to attract the cotton ballworms to the pheromones. And we had different treatments of pheromones, and we followed the flight tracks of the moths. So we had a uniform dispersed treatment of the pheromones, or we had the pheromones grouped together, or we had a control with no pheromones. And we also recorded bat activity using acoustic detectors because these moths have hearing organs and they can change their flight patterns in order to avoid predation by bats. Altogether, we had 12 replicates of each treatment, and we had 1 hour sessions of recording. We analyzed 10 minutes of the recording. So this is an example of 10 minutes of each of the treatments. And you can already see that the density of flight tracks in the group treatment was much higher compared to the 2 other treatments. And also that the activity tended to cluster around where we located the pheromones. We also found that the movement properties of the insects changed between the different treatments. So the moths in the group treatment in this color were flying for a longer duration, for over a longer distance, but they were flying in lower speed and also less straight compared to the 2 other treatments. Actually, it was only significant mostly compared to the control with no pheromones. While we did record bat activity during our experiment, we found that it had no effect on the movement patterns of the insects. And we think that this is because the main bats that were active during our experiments, they target smaller prey. So the cotton ballworms simply ignore their echolocation calls. So altogether, we think event-based cameras are a promising technology for the insect monitoring toolbox. Here we generated a data set of 6 hours of recording and almost 2,000 insect flight tracks. And we think that there is more to get out of this data set. For example, categorizing behavioral states or looking at wing beat patterns. So like you can see here, this is something that we can observe with this camera. And mind you, this is 12 meters away from the focal point. So it's something that a frame-based camera would probably not be able to achieve. So if somebody wants to explore applying AI to this data set, please reach out to me during the break and we can maybe think of doing something together. And the last thing is I want to acknowledge Omri for co-leading this study together with me. Without him, I would not have any results to show you today. So that's it. Thank you, everybody.
One question for you. Well,
thank you very much for the output of event camera is in the form of time step, right? The pixel location and XY direction and the polarization.